Hey there everyone, and welcome to another video. And in this video, I'd like to show you guys a little bit of a proof of concept that I wrote. It is, as you can probably tell by the title of the Visual Studio project, it is Steering Wheel Pong. Now, my sort of shtick lately with things like ShiftOS is Pong. Like, it is the go-to, it's basically my hello world of a game programming library, or game programming library. Like, when I learned C++ and SDL2, I did Pong. When I learned MonoGame, I did Pong. When I learned how to do MonoGame on Android, I did Pong. And when I learned WinForms, I did Pong. And I haven't done Pong in Unreal because I don't know how, but now I've got one of those Logitech racing wheel and gas/brake pedal thingies that you hook up through USB. And they're used for racing games until now, because if I launch this is Pong. You'll notice that it is a little bit lopsided, and you'll notice that I'm a little slippery with my controls. The game is a little buggy because I've literally only been programming it for a max 2 hours combined. So it's not the greatest Pong experience ever, and the bottom paddle is the player, the top paddle is the CPU, and it's not like ShiftOS Pong where there's levels and stuff like that. It's like classic arcade Pong. If you get the ball past the opponent, you get a point. If they get it past you, they get a point, and that's basically the game. The velocity and everything is all messed up because, of course, bugs, but I've implemented a basic Philip Adams style Pong API, or Pong AI, so the CPU panel will basically see how, it'll see if it's, if the ball's near it. If it's not, it'll try to go to it, and it's limited as far as how fast it can go to the ball, so that there is a chance to beat it, but it will actually try to beat you. But there's a bug. That's a dead zone issue. The top left corner, there's actually text that tells you the status of the steering wheel. These steering wheels, they actually use DirectInput for, basically what that means is you can actually read them as if they are, normal, what do you call it, gamepads or joysticks, so, like an Xbox 360 controller or something like that, or any garden value USB gamepad, you can read it through something called DirectInput. And that's what I'm using to read the steering wheel. Now, luckily, MonoGame has a DirectInput API built into it. There are two gamepad APIs in MonoGame. There's the gamepad class and there's the joystick class. The gamepad class is your Xbox One controllers and your other X input devices. Those are things that Windows 10 will recognize natively as an Xbox controller, and most games will see them as an Xbox controller. But then you have your Joystick API, which is for older controllers that use the older DirectInput API, and that's for things that aren't Xbox One or Xbox 360 controllers and stuff like that. So like your Logitech gamepads and your steering wheels will all go through DirectInput. And the funny thing is, the steering wheels, at least this one, actually treat the horizontal axis of the left thumbstick as the steering wheel axis. So, if I steer all the way to the left here, or, yeah, to the right here, my paddle's to the right now, and if I let go, it should... Oh, it jumped a little. That's the dead zone issue. I had to code the dead zone on my own. But if I steer all the way to the right, it's like putting a thumbstick all the way to the right. It's the same sort of input, as far as the program is concerned. And if I steer to the left, it's the same thing. Now, I have the gas and brake pedals as well, but those aren't, they're not treated as input by this specific game, and I'm getting annihilated as I talk here. They're not treated as input, but if I wanted to, they would be another axis. I believe your brake pedal is the up and down axis of left thumbstick, and then your gas pedal would be right thumbstick up and down. I could be wrong. Some games recognize them both as left stick up and down. But either way, your steering wheel is basically the first axis you can track. So this could actually be ported to SDL2 with minimal work. But yeah. This isn't really meant to be a good Pong game. It's more of a demonstration of how easy it is to work with these steering wheels in MonoGame. And I'll actually show you the code real quick. It's not commented, but I'll go through it. I won't go through the actual Pong code, just the gamepad stuff. So the first thing I do is, of course, I set up MonoGame. I make sure that I have a graphics device manager. I'm running the game at 1366 by 768. That's fine. And fixed time step just means that I can only run at a maximum 60 frames per second, I believe. Or only render that much. That just means that I'm rendering at my native refresh rate, or below if something's happening. But for the most part, MonoGame will try to keep me at 60 frames. Or 60 hertz. But anyway, the big stuff is in Initialize. This is where I actually find the gamepad that I want to use. So I have a few variables up the top. I have an X input variable and a slot variable. And these are how I figure out what gamepad or joystick I want to read input from. So if I go, or if I look at here, I've got slot equals -1 and then X input equals false. That should be true by default. I'm going to fix that. But in Initialize, what I do is, well, I'm trying to figure out what gamepad I want to use for input. I'm going to find a steering wheel. So first I'm going to prioritize X input, just in case someone has an X input device connected that happens to be a steering wheel. So I go through the first 32 devices, because realistically, who the hell in this planet is ever going to have 32 X input devices at once? So that felt like a good number. And MonoGame won't crash if you try to grab at a gamepad that doesn't exist. So what I do is for each slot index, I guess, starting at 0 and working my way up to 32, I grab the gamepad state for that slot, and I check if the gamepad on that slot is connected, and that's why MonoGame won't crash, because sometimes there can be missing, or the gamepad can be disconnected. So it's a good way to tell if you have a player connected to a certain slot. So if you wanted to implement a multiplayer game that was gamepad based, you could actually tell if there's a second player by checking slot 1 to see if it's connected. But anyway, if I see that the slot is connected, then I try to get its capabilities. This tells me information about the gamepad, what it can do, what buttons it has, what thumbsticks it has, and what type of gamepad it is, and that's what we're interested in. So I check the gamepad type to see if it is a gamepad type of wheel, which is the X input designation for one of these steering wheels. And if it happens to be a wheel, then I set my slot to whatever slot I'm currently on, and I break the loop. That's all I need to do. If slot is still equal to -1, then I haven't found an X input device, so it's time to check direct input. So X input becomes false. And that's actually important, knowing which one I found. So then I do the same thing. I go through the first 32 direct input devices, because who is going to use 32 direct input devices with this game? But anyway, I use, it's basically the same thing. I grab the joystick state at that slot. Joystick is just an older way of saying gamepad, but if the joystick is connected, then what I will actually do is I will again get its capabilities. Now, unfortunately, DirectInput and MonoGame does not expose any way to see exactly what type of controller it is, so I can't do that. So instead what I do is, well, first I'll try to see if maybe the identifier contains the word wheel in it. I believe my racing wheel actually calls itself a racing wheel, so that should work. But if that's not the case, then I'll fall back to something that has at least one analog input on it. And if I do find either one of those, whatever controller comes first, maybe it might not end up being a steering wheel, but who cares? In my case, it is, and that works. I set my slot, and then I break the loop. And then if the slot is still -1, then I crash, because at that point there's no gamepad connected. Anyway, this is all a bunch of stuff for sprite fonts and stuff like that, loading in a TTF file, so that doesn't really matter. The next thing that I do every frame is I check, okay, are we using X input? If we are, then it's easy. We literally just grab the gamepad state of our slot, and then we set wheel pose to whatever the left thumbstick's X value happens to be, and that'll be a value between -1 and +1. It'll be a floating point. Otherwise, if we're direct input, then I'll grab the joystick state for the current slot, and I will get the value of axis 0 on the joystick, because there's no designation for thumbsticks. You just have an array of axes, and the first axis is going to be axis 0, and that's going to give me the steering wheel, hopefully the steering wheel's current position. And this is going to be a 16-bit signed integer that I'm going to get back. So I have to do some math on it. And what I do is I want to get it between -1 and +1, so basically what I do is a sort of dirty way of doing it. I convert the joy value to a float. So right now it's an unsigned 16-bit integer. Or no, a signed 16-bit integer, meaning it can be between something like 32.7 thousand and -32.7 thousand, something like that. I convert that to a float, and I divide it by the maximum value of a signed 16-bit integer, short.max value, which is 32,768. And what that does is if the steering wheel happens to be steered all the way to the left, it's going to read as -32,768. That divided by 32,768 is going to be -1, give or take. Depends if there's a rounding error or something. But yeah, that's the percentage value I want, between -1 and +1 as a floating point. That's easy to work with. But then the problem comes in with dead zones. You may see this sort of setting in emulators or older games, maybe. But what happens is analog sticks, analog inputs are not perfect. They don't always read the same value when they're at the resting position. And in the case of a steering wheel, well, when it's at the resting position, you would think it would read a 0, meaning there's no input in either direction. Well, got a newsflash for you, gravity exists, so no matter how hard you try, it's always going to be slightly to the left or to the right. At least the computer's gonna think that. There's no way to get a true 0 unless you have, like, ninja fingers and can just ever so slightly move the steering wheel and not have it fall in a direction or something, or God knows how you would figure that out. But that's why dead zones exist. They basically say if the analog reading is below a certain value, then it might as well be 0. It's like a margin of error, basically. So what I do is, if the absolute percentage of the steering wheel position in either direction is less than 5%, then it might as well be 0, because at that point, you're, like, talking about micro movements, and, yeah, it's really not going to make it, I had this issue in Grand Theft Auto where I would veer slightly to the right or to the left, even though I wasn't having my hands on the wheel, because my dead zone was set incorrectly, and I was having the same issue in this game, too. But, yeah, do my dead zone calculations, and then at the end of that becomes my wheel pose. And I'll actually show you what happens if you take the dead zone out of the equation, by setting it to 0%. Yeah, and then I'm going to, yeah, just lightly tapped my wheel, and I think I'm moving a little bit to the left. But, yeah, see, now I let go of the wheel after moving it slightly to the left, and now it's steering on its own. And I can probably get it to the right. I think there's like a loose screw or something that's causing that, but oh well, that happens. That's why dead zones exist. But yeah, now it's going slightly to the right because I touched it a little. Yeah, you can see I'm basically just feeling around my steering wheel, and it's causing it to go in different directions, and it's, yeah, this would be very frustrating in a racing game, but it's Pong, so, but yeah, better dead zone would be 10%, instead of 5%, yeah, see, now I move it slightly to the left, and it goes back to its resting position, and my paddle stays still. So yeah, that's how it should be. That's how a dead zone works. I should probably do the same for X input, but I have no way of testing it. And what I can also do is I can pair an Xbox One controller with it, and restart the game. And because my Xbox controller is not a steering wheel. Oh, wait, never mind. It saw it as a direct input device and it fell back. That's embarrassing. Okay, so don't connect an Xbox controller. It'll treat the analog stick as a steering wheel, and that's not what you want. It's a little overpowered. I crashed the game. I turned the Xbox controller off and it crashed the game. That's amazing. Oops. Anyway, just a little proof of concept. Steering wheel Pong. Someone will find it interesting, I hope. But anyway, I've been Michael, and I will see you guys in the next video. Thanks for watching.